We have 4 resistors here, and we have to find the equivalent resistance of the whole circuit. So it's actually easier to look away from the battery. So let's start at the right hand side, and let's start to see if there are any patterns. Do you see anything in series? Do you see anything in parallel? So if you are looking here on this loop, you see that R2 and R3 are in parallel. The way to look at it is if you go from, say, R2 to R3, and then you see that I did not have any other resistors or batteries in this path. It was a clear path from R2 to R3, and then also I can look at the other side, so they both have to be the same. So go like this. I did not run into any resistors or batteries or anything else. In that case, they are in parallel. So R2 and R3 are in parallel. So when they're in parallel, let's find the equivalent resistance of just R2 and R3. Let's call it R23. So when in parallel, we do 1 over R23 is equal to 1 over 20 plus 1 over 20. That gives us 2 over 20, and that gives us 1 over 10. And what we need to find here is R23. So R23 is equal to 10 ohms. So that means this entire blob here is 10 ohms. So if we were to draw this again, what we'll draw is we draw a battery, we draw R1, and here we have R4, and then instead of the blob we have R23. So this is the battery. So now you see that they are in series. If you have a certain amount of current that goes through here, and this is like water in a pipe, and it goes through the resistor 1, and then we go through resistor 2. There are no branches whatsoever. All the water is flowing in the pipe or in the wires, all the current, and goes like that. So if we had any other branches here or here or here, then they would not be in series. So it's important to go over and see if there are any other branches. So in case these are not have any branches, so we know that R1, R23, R4, they are all in series with each other. So R equivalent, when they're in series, you can just add up the value. So R1 is 5, R23 is 10, R4 is 15, so that is 30 ohms. What if this told us that V is 60 volts, and then to find the current that goes through the battery? So in that case, we had to look at the entire circuit. So that means here also this is the same I1 that's going through. So let's do Ohm's law. We have V equals IR, I1 in this case, and V in the battery is 60. I1 times R, which we are going to use Req because we are using the whole circuit, and that is 30. So I1 is 60 divided by 30, which is 2 amps, which means here it is 2 amps. So the current flows through here and then goes here, and you see that there's a junction here. Because there's a junction here, we have an let's call it I3 and an I2. So the 2 amps split, and then it comes down here. one of them comes here, and then they meet up at this junction and then go together again as 2A. So how do we find I2 and I3? Only because R2 and R3 have the same resistance. It's the same resistance, and there's no other resistors or batteries or anything in here. The 2 amps actually divide exactly into 2. So this will be 1 amp will be I3 and 1 amp will be I2. You can only do that if these are of the same value.